to attempt to share. Okay, now I have, it says you've disabled screen sharing. Can you make me a co-host, please?
Oh, all right, sorry. Okay, there you go.
All right. Okay, so hello, welcome. This is the Kubernetes SIG storage community meeting on the topic of per volume CSI capabilities. We missed last week because I think a bunch of people were out on holiday, and the prior 2 weeks we only got a little bit done because we didn't have Michelle. Michelle, are you here with us today?
Yeah, she's there.
I am here.
Oh, good. Oh, and you have audio.
Works.
You fixed the audio. Excellent. All right. Let me put this on here. All right. So Michelle, where we had come down was I had a specific proposal that basically was a combination of, I'm trying to go back in history and remember when the last time you met with us was. Yeah, it was a combination of the second and third option, bringing or updating the CSI spec and then extending the current CSI driver. And the specific proposal was basically to modify the persistent volume API object with this new field called subtype, which is going to be a sibling of the driver field. So, you know, right now, all of your different CSI drivers have their names. The idea would be to have a subtype under that name, which would be a vendor specific, and it would be filled in by modifying the CSI spec with this new subtype field on the volume object, which is returned in the create volume response. And this would, of course, have to go through alpha GA on the CSI side. On the Kubernetes side, this would be a new alpha field and have to go through alpha beta GA. It would default to being empty, obviously, because it's a new field, so it would have to default to being empty, in which case you get exactly the same behavior as today. But the idea is for drivers that want to opt into this subtype behavior, they could return this value at create volume time. Kubernetes would store it in the PV object if it was available. And then when kubelet was doing the various things that it does that where you might want to have different behavior on a per volume basis, you would be able to go look at the subtype field of the PV and decide what to do. So if it was a question of the group ownership change policy, you could have different policies for different volumes. If it was a question of the SE Linux labeling policy, you could have different values for different volumes. The one thing that this basic solution doesn't solve directly is the node volume limits. And so to address that, I proposed additionally in the node get info response, where we currently return a single field, which is max volumes per node, to return a map that is subtype max volumes per node that would let a driver in principle return a map of values so that different subtypes could have different maximum volume counts. Now, we would also need to plumb this all the way through to where the Kubernetes scheduler can get it. And I don't have a specific proposal for that, but I'm sure you can imagine what that might look like. And so this was my high level proposal. The reason that we did not like option one was no matter what we thought of in terms of changing, you know, the way sidecars work or changing the way that kubelet manages node plugins, you know, regarding the design where you would have just multiple CSI drivers, was that no matter what we do, you can't get around the fact that a storage class only specifies a single CSI driver. And today, that enables you to do the kind of thing we do where like you only have one storage class and you only have one CSI driver, and it can decide like whether to give you NFS or iSCSI based on the specifics of your request. And and the proposal where we just have multiple CSI drivers would break that, right? You would no longer be able to just have one storage class and then let the CSI driver decide. You would need to have multiple storage classes and It would, and if somebody wanted to get the default storage class behavior, they would be stuck with exactly one of those storage classes. So for example, if you had an iSCSI and NFS, you'd have to pick one to be the default, and then you'd always get that, which would be a step backwards from what we have today. So that was the biggest knock against the, let's just split into multiple CSI drivers. I mean, the multiple CSI drivers has some architectural cleanliness, but there's a lot of work to do there. And we couldn't get around the storage class problem.
So I guess if my understanding is correct, basically users don't specify the subtype. It automatically gets filled in when a volume is provisioned.
Even admins don't specify, right? When an admin fills out a storage class, they do put the CSI driver name in the storage class, and that determines which CSI driver will be your provisioner for that storage class. But yes, in this case, the driver fills in the subtype, and only if they want to, right? If the driver has legacy behavior or doesn't want to have subtypes, it's just blank string, and you get the exact current behavior.
I guess the part that I think might be challenging is for the features where we need things to be done. We basically need the subtype to be determined before provisioning. So that does include things like the volume limits and the storage capacity things. Like all of these things are reported before provisioning takes place, so we don't know the subtype ahead of time.
Right. So for the volume limits, this node get info response is just, this doesn't require a volume to exist, right? This could be hard-coded, right?
So like kubelet can publish node limits based off of the subtype, but when the scheduler is processing a PVC, it only has the PVC in the storage class. So how does it know from PVC in the storage class which subtype limit it should be looking for?
Well, it can't find the PV that is bound to that PVC and then look at its subtype?
No, because this is potentially before provisioning, right? Before a PV actually exists.
Okay, it didn't occur to me that the scheduler might schedule a pod attached to a PVC that wasn't bound yet. So you're saying that can happen?
This is for the delayed binding mode that we have, right? And that's all the scheduler related features like node limit, volume limits, and storage capacity.
This does throw a wrench into that. Yeah. Okay, so the concern, I'm just trying to play this back because I haven't thought of this before. So the concern is, I'm trying to schedule a pod. It's going to be attached to a PVC that doesn't exist yet. I need to know if I can schedule it to a given node, which has a limit on how many volumes can be attached to it, but I don't know what the kind of volume I'm going to get is. So I can't safely put the pod on a node, knowing that after it lands there, I'll be, the PV will be able to bind and that it will be able to attach, because I don't know the subtype. Boy, that's a hard problem.
Yeah, it is. Like, I think unless you have a way on like the storage class to also specify the subtype.
But you don't want to, right? Like that's the whole thing.
The purpose, right?
Yeah. I mean, so that's a bit of a serious wound to the volume limits application of this solution. And maybe that does need a fundamentally different approach that we need to think about. But what do you think about this for just the other two problems that we're aware of, like the stuff related to kubelet needing to look up some policy behavior in the CSI driver CR? With this solution, we could use the subtype to look up in a map of policy values in the CSI driver object and get better behavior.
I see. So like for say FS group and SE Linux, as an example,
Mhm.
you could have like the CSI driver object.
Could have a
You
new
could
field
create
with like
one
with a map.
CSI driver per subtype. or
Well,
something.
we could do it that way, right? We could have a CSI driver per subtype, or we could have change the CSI driver object itself to have new fields, which were map fields, where you would just have, instead of FS group policy being a scalar value, you'd have FS group policy map, which would be have keys which were the subtypes and values which was the policy value.
Mhm.
So
Yeah,
you could
I
do it
mean,
that
I
way.
think
Go ahead.
it seems that approach seems feasible for at least those problems, right?
Yeah.
I think it is these scheduling ones that are the harder one to
Yeah.
figure out, I think.
Um,
I think Hamad also had some discussion topics that he wanted to discuss.
Yeah,
Okay.
just the last call, I want like we kind of started to talk about how can we make it easier to like migrate, or there's two things. One is how can we make multiple drivers to run potentially within the same, not even pod, but within the same. There's one that they can run as same pod but different containers. Second is that they could run within the same part of the same process. So okay, so we talked about this briefly in the last call, and I was thinking more about like same container problem is kind of same pod problem is relatively solvable, because you can bind to different sockets, and you can like Unix sockets, and they can return different values of get plugin info, and that's all fine. But same process is more tedious, because then yeah, it will require, I think, changes into the CSI, uh, at least like identity calls, like get volume info and things like that, where it has to report multiple things on the same.
So hold on.
socket.
I'm trying to think through are we talking about controller plugins or node plugins right now?
I'm actually talking about like both in general, because the deployment mechanism.
But I mean, but the snags are very different for each one. So if we focus on controller plugins, you're saying I might want to run two different CSI drivers in one pod, and in that case, I can just have maybe multiple instances of the actual driver, and then multiple instances of each sidecar, and point them all at the correct two different sockets, map them all correctly, and then the right thing happens inside one pod. Is that what you're saying on the controller?
Yeah, that's one way of solving. That's one way of solving it. But given that we also wanted, like, I don't know if it's still a goal, like to reduce the memory footprint on the node, and that basically on the node side, then we are talking about either like letting multiple, like,
Well, hold on. I mean, so
yeah.
the memory footprint on the controller side, are we saying that we don't care about that?
We do care about that. We do care about that, but that's why if we decide to solve this by allowing multiple plugins to run in the same process, it will solve both controller and the node side. If we take this middle approach where you have like multiple drivers running in different containers, but maybe as a part of same pod, then
I guess I'm not grasping what the challenge is. Like, no matter, as long as you have two different sockets, they can both be listened to by the same process, right? And then that process can do the work of two drivers with two different Go threads or Go routines. And you can economize on memory, at least for the driver, that way, right? And then we could, in principle, do the same thing with the CSI sidecars. We could make an omnibus sidecar, or we could make a sidecar that knew about multiple drivers, and then allow you to combine all your sidecars down. So best case scenario is like one container running the driver and one container running the omnibus sidecar, and both of them doing both things over multiple sockets.
yes. So
right? That's the best case for the controller plugin. But then for the node plugin, it's kubelet that's talking to the socket, right?
I was thinking also about how the node registration will work in the case of kubelet, because the node registrar calls I think it calls get plugin info call on the driver. So
Right, but you could play the same game where you had two different sockets on
yeah,
the node and two
but
different node registrar sidecars attached to the different sockets, and they would get different results back because they're different sockets, right?
yeah. So we will be running in that case like currently node. So it will require a change in node registrar, right? So that you can watch for, like right now we are deploying one node registrar, I think, for each plugin. And if we have,
But I mean, I just want to understand, like, obviously we could change the node registrar to do whatever we want, but like, even if you don't change it, couldn't you just run two of them, one attached to each socket,
we
and
could,
still get the correct behavior?
yeah, we could, but yeah, we could
Okay.
in the interest of, yeah.
Okay.
So the
So
reducing,
there's nothing stopping someone from doing this today. It's just that it wastes a little bit of memory, and we're saying maybe we should make these things smarter so that one can do the job of many
yeah,
and save
okay.
memory.
Like you could consider like taking it in phases, right? Like first phase is, you know, do a sidecar per socket. And then second phase would be, you know, consolidate all the sidecars.
What I mean, no, I think what you meant to say, and tell me if I'm wrong, is the first phase is make each sidecar able to handle an array of sockets instead of just one, right? And then later, once all the sidecars can do that, collapse all the sidecars down into like an omnibus sidecar that just does all of the things in one process.
Or is the first phase like have the driver expose multiple sockets?
But you can do that today, I think. That was my argument. Nothing stops you from doing that right now.
Yeah. No, definitely it's doable. Except like I think you'll have to just run multiple version of node registrar. So running multiple drivers.
But Hamon, are you sure that would work? Because I know there's some weirdness with how the things get registered on the node, and exactly how kubelet finds that socket. I'm just, I could believe that it works, but not having tried it, I would want to hear that somebody had actually tried it and made it work.
No, I think okay. So I was just looking at the code of the node registrar. It finds the socket location from wherever we specified during the startup, like the CSI address, whichever path that we specified, and it's a required argument, and then it just calls get plugin info on it. So
and how does kubelet find it?
The kubelet, it also accepts a plugin registration path and kubelet registration path to different. I think kubelet registration path is the one that that's shared between kubelet and the node registrar.
Right. And if you put two sockets in there, does kubelet find both of them? Because that's what you need, right?
You can't. It's a string. So I'm not sure you can put two sockets there.
Right. So that's where my concern comes in, is in the glue between the node plugin and kubelet. What we would need would be to have two sockets for that kubelet knew about, right? One for the one driver and the other for the other driver, because kubelet isn't going to multiplex multiple drivers over the same socket. So we would have to solve that part of the problem in terms of how kubelet finds the socket to talk to.
Yeah, totally. Or like for the as phase one, as you said, we could run two node registrars basically, like so that we don't have to. Then it would be simpler. So it's like assuming node registrar doesn't take too much memory. So it's like you have two drivers could run as same process but different. They listen on different unique sockets, but but the copies of you're still running copies of node registrar for each plugin, each socket. That could work as phase one. In future, we could enhance the node registrar to listen to an array so that it handles this correctly, but it would require changes into node registrar and the registration mechanism.
Okay.
It-
How about the idea of kubelet knowing how to start plugins itself and then allowing them to like not run unless they're needed?
It's difficult to do.
Yeah, but I mean, in a world where you have like 5 CSI plugins in your cluster and you're not using all of them on all of your nodes, you could save a tremendous amount of memory by like, keeping them cold and starting them up on demand.
But it's like it's again, it has to be. We can't say that for sure, because once you start a driver, like unless we also say that, okay, if last volume gets unmounted, not unpublished, then I'm going to shut down the driver.
Well, yeah. So that I think that's the other problem we have that would be solved by this. Like today we have this issue where when you drain a node, if kubelet happens to kill the CSI node plugin while there's still attached volumes, you're screwed. And so the way we solve it is by like giving these CSI node plugins ridiculously high priority so they're like the last to die. But it would be better if kubelet just knew which CSI plugins, or first of all, which pods were CSI plugins, because it doesn't know, right? That's why it kills them out of order sometimes. If it knew which ones were CSI plugins, it could keep them around until the last volume attachment was gone. And furthermore, if it knew which one was responsible for which CSI driver, it could kill them even before you drain the node, right? It could say, oh, that was the last attachment for the NetApp driver, let's shut it down, save some memory. And the next time a NetApp volume attaches to that node, it can say, it can look around, notice there's none running and just start it up. And then if you had nodes that weren't using any PVs, you would just save a bunch of memory on those nodes.
And the challenge is obviously like the scheduling will be a challenge, because they had the drivers running on the node report a limit and report, okay, they're available. Now, if they don't run on the node until something is scheduled, that they won't report anything by default.
That's a good point. But I mean, but you could solve that problem by like starting it up, doing the query, and then shutting it down, and then doing that on some frequency.
The
Like once every 24 hours.
The scheduler folks are very, very conservative about accepting resources that can change a lot. Like,
how often do we currently poll the driver for its node limits?
CSI node, I think it's cached quite a bit, actually. I'll have to check.
So I'm assuming that it doesn't change in practice, right? That once the node plugin reports a value, the system is going to assume that value is constant for a very long period. And so the moment you get one value out of the node, you might not ever need to ask again.
Yeah, until you, like, the whole CSI node object is rebuilt or something like that.
Right. So that wouldn't be too big of a deal if we just had to start up the plugin to make one call and then shut it down. In a world where like the answer to this problem is lots of CSI plugins, I feel like we have to do something about the fact that every CSI plugin or node plugin runs on every node. And some of these things consume, hundreds of megas of RAM. But, maybe...
yeah, I mean, we could say that as a phase 3, but it requires even it requires more design than even phase 1, phase 2. So of this, like, better ways of running drivers.
I feel like that's going to have more payoff than trying to squeeze multiple drivers into one plugin. I mean, I agree that that's also something it would be nice to be able to do, but they're always going to be, if you have multiple CSI plugins from different vendors or different CSI plugins for different purposes, they're never going to be combined. They're just going to be separate. And the ability to not run them on all of your nodes all the time would be a dramatic improvement.
I think for the most part, we've managed to kind of get by this by just you know, having the, you know, admin sort of just decide and pick and choose what they run.
Mhm.
And so you could just say, you know, the admin will say, I only run, you know, this driver on this node pool or something like that. You can use like node selectors and other things to selectively deploy your driver.
That's true. If you modify the daemon set, and then you also ensure that every pod that uses that type of volume is bound to the same group of nodes, you could stay out of trouble. But I guess it continues to bother me that we have this flaw where when you drain the node, the CSI plugin can actually get killed too early because Kubelet doesn't know that it's a CSI plugin. It would be nice if there was a way to flag it as like, this pod is a CSI plugin, and please keep it alive until the last volume attachment is removed.
Yeah. So I haven't thought a whole lot about this problem, and I think it's running drivers on demand. It's interesting problem, but I don't know. I haven't thought a lot about it. It's kind of challenging, but I also want to spend some time, like while Michelle is here, this thing that we talked in last call, the driver selection if single storage class is specified. So one of the problem that you mentioned, Ben, was that so even if we manage to run multiple drivers, either a sidecar, same process, doesn't matter. You're still left with the problem that currently those drivers are deployed with single storage classes. Like not always, like in some cases, Azure case, for example, it deploys actually different drivers, Azure file. But yeah, in other cases, it's possible that they deploy a single storage class, and based on access mode that gets passed to the CSI driver, it provisions different kind of volumes, like vSphere CSI driver provisions read write
Yeah.
many
I mean,
yeah.
That's how the NetApp one works, and other things can impact it too. Like, you know, we can decide to schedule larger volumes as NFS and smaller volumes as iSCSI, or, you know, block. Well, obviously, if it's a raw block volume, you're going to get iSCSI, and if it's a file system volume, you can get either. So like other aspects to the PVC can determine what you get, even with just one storage class. And it can come down to just like which one we happen to have free space for at the moment, right? We could be out of NFS space and we're going to give you iSCSI or vice versa.
Oh, okay.
Right? I mean,
yeah. So okay, interesting. So I was talking about the last call that, like, if we decide to, so there are two things. One is like for the problem that admission plugin can do this, but it's not clear how multiple drivers with that mechanism would coexist. Like in
right.
my mind, I was thinking basically admission plugin will do the same thing that CSI driver is currently doing, and assign a specific storage class based on, like, you have a default storage class in the clusters, and then it's
Right,
like,
but that admission plugin could only do its work on PVCs where there was no storage class specified.
yeah.
Right. And so today, if you have two different CSI drivers from two different vendors, you can still pick which one you get with the storage class, and then after you pick the storage class, still get another scheduling process of what exact kind of volume is the CSI driver going to give you. The NetApp driver has a whole scheduler inside of it, right, that looks at possibly multiple storage backends and tries to make the best decision, and it has a retry loop. So if anything fails, it just keeps retrying on the next one, until it finds one that succeeds, or it exhausts every possible option.
So this is only for like when user does not specify a storage class.
No, like today, any storage class that has the NetApp CSI driver will go to our plugin, and then the scheduling will happen because we only have one CSI driver, right? And all of the different possible volumes NetApp can give you are all umbrellaed under that single CSI driver. And we pretend, as far as Kubernetes is concerned, that they're all the same. Kubernetes has no idea that we're dealing with iSCSI and NFS and weird flavors of block on file and soon to be NVMe. and whatever else we imagine. Like they're all in there, and it's just multiplexed over the Trident CSI driver type. Hello?
Yeah, I know, I'm just thinking.
Okay.
So
Yeah.
so yeah, like, and all these volume types are immediate binding or delayed binding, because like like if you are delayed binding, then this sounds like it's interacting with scheduler that built into Kubernetes, and then there's the
So
driver
the
has.
binding mode is up to the end user, right? Like we can do immediate or delayed. And if you do delayed binding, all that happens is we wait until the pod lands on a node, then we do the thing we were going to do anyways, which was run it through the scheduler. We just happen to know what we happen to have extra topology information in that case, if it matters.
The binding mode is, I think, up to the storage class. So yeah, users cannot choose binding mode. But yeah.
Okay.
Hmm.
Okay, I guess I could believe that. But I mean, the point is our driver doesn't care, right? Because we're just going to get a create volume call at some point, and whether it's after or it's before the pod is scheduled or after the pod is scheduled, we're going to do the same thing. So we support both. And if it is after the pod is scheduled and we have topology information and that matters, then we will use it. Because we do have a flavor of driver that, you know, is built in the cloud. Like I think we have a Azure NetApp files, which is part of Microsoft's Azure cloud. And like if you're in a certain region or zone, it will make sure that the storage is in the same region or zone if it can. Those kinds of things. But at the end of the day, like, you know, if you're just using ordinary like ONTAP storage, we'll just schedule it, and then, you know, it'll go across the network to from wherever it is to wherever it needs to be.
Yeah, I was thinking like generally like admission hook would work in some cases, like where you just are basically doing a decision of, okay, there's no storage class in the PVC, and you want to assign a specific storage class based on what was there in the PVC, then admission
Yeah.
hook could work. But if we are talking about like complex decision making, I wonder like will it be like too late? So when the, for example, then when the if these calls get executed by a webhook, then I wonder if it'll be too expensive to factor into like scheduling the decision that scheduler is doing, and then this web gets executed when a PV is
Yeah.
created.
Probably, yeah, because the kinds of things that our scheduler would do is actually try to create the volume, and then if it succeeds, great, and if it doesn't, it'll try another place, and it goes through a retry loop inside of the create call. So if we had to do all of that in some sort of an admission hook, then by the time that the admission hook set the storage class, we would have already created the volume somewhere, and it could have possibly taken, you know, 5, 10, 15 seconds. Or longer, now that I think about it. We have some drivers that are extraordinarily slow, and it could take 90 seconds. So yeah, like we definitely rely on the fact that create volume can fail and retry, so that very slow volume creations eventually succeed.
Michelle, you there? Like, I just want to yeah, ask your opinion on like, is it different from like the current code where like the create volume anyway will get executed during the binding process, and that happens for delayed binding at least during the scheduling. So is it different if the scheduler it happens during the scheduling versus it happens as a part of a webhook? Like at least the
You mean the create volume part?
yeah,
Or the storage class assignment?
No, the create volume part.
If you create a volume as part of a webhook.
Yeah. If you call create volume, like okay, currently like in for CSI driver, for those that support dynamic provisioning and delayed binding, the scheduler picks a node and first it creates, I think the binding code creates a PBI. I forgot the order in which it's done
Well,
actually.
it would have to first pick the default storage class because it needs a storage class to pick the node, right?
Yeah, that's done by I think the admission hook. The default
Right, but
storage
the
class.
change you're proposing is that like we do something even before that, where if the storage class is blank, we run some vendor specific logic and then fill in a vendor selected storage class for you to deal with the fact that, you know, if you have multiple CSI drivers and you want to pick one based on the request, you need, you know, and admission hook is the only way to do that. But that would happen even before schedule. The nodes could get scheduled, right? Because you'd have to set the storage class in your webhook. I don't know. I guess my feeling on that class of proposals is I think it could work, but it would be like a massive re-architecture for something like Trident to work that way, and I don't see it happening. Like even if like that was the agreed upon path forward, we probably would just decide not to implement it and keep doing what we're doing and live with the limitations thereof. Because the effort to change is so high.
I guess one of the challenges is like, what would you sort of define as the sort of the selection mechanism? Like, I think if we went and said, you know, we want to support default storage class per access mode, then I think that would be something that would be pretty feasible to implement. But if we wanted it to be more like dynamic and be like not just access mode, but also these other fields and maybe
Like volume mode matters a lot,
yeah,
right?
yeah. Then you know, once we start allowing like arbitrary sets of fields to determine which storage class to use, then that it starts getting very tricky.
Yeah, I mean, while we could have gone down that path years ago, like the fact that we've done what we've done makes it seem unlikely we'll ever get out of the situation of just having one giant CSI driver name and one storage class for a particular vendor. I feel like we're stuck in that, you know, on that path now, just due to momentum. And that's why I was saying, you know, well, a subtype would help us move forward. You know, we would have its own level of grossness, but at least we wouldn't be backtracking and, you know, starting over with how do you know, how many storage classes do you need and how many CSI drivers do you need and how do you migrate from your current situation to that situation?
Yeah, I mean, I think as long as the decision making is in like, yeah, based on access mode, volume mode, those things are simpler, but based like anything else is like complicated. Yeah, I guess I don't like, I have to like, it's just, yeah, it's hard to see the use case, like every use case. Like I see, but how it will work in practice and it just kind of, yeah. The subtype proposal works for like FS group, SLNX, those properties that are determined by
Wait, and we might be able to find a way to make it work for the node limits. We just have to think through the scenario that Michelle laid out, because I hadn't occurred to me before.
Yeah, so the problem is that you have storage class and you have I think you have PVC, and you don't have anything else. So you don't know, like,
Like what you could do in that case. My specific proposal for the volume node limits was, there is a fallback, right? You don't remove the existing node limit that, for the empty subtype, which is, the legacy behavior. You just add specific volume limits for specific subtypes, and those could be higher or lower than the default. You could just continue to use the default for ones where you don't know the subtype, and then as long as, and then you could set a rule that says, okay, as long as the default is less than or equal to the subtype specific volume limit, you will get the correct behavior, because the scheduler will never pick a node that doesn't have the minimum, or doesn't have fewer than the minimum number of attachments left. And you could get correct behavior. Now the effect of that would be to artificially limit the number of deferred binding volumes on a node to whatever the node limit was for all of the subtypes for that particular driver. But that doesn't seem like the worst thing, right? Like if let's say for whatever reason we could only have 32 NFS volumes, but we could have 100 iSCSI volumes, you could just set the default limit to 32. So you could at least get 32 volumes of NetApp type. And then if it happened to be iSCSI, then you would know, okay, well, it's actually 100 for that. And you could use that limit to schedule more in.
how would you schedule more in? If the limit was 32, it will stay that, right?
But for non-delayed binding volumes, for ones that had a PV, you could go look at the PV and see that it already existed and see that it was iSCSI, and then say, oh, I'm going to use the limit of 100 instead of the limit of 32, because I know. But when you don't know, you could just default to the 32 and say, well, I know that that's the safe number, right? I know I'm not going to get in trouble if I go up to 32.
Yeah, so anybody who wants to use the higher than that limit, they'll have to pretty much use like.
They'd have to do immediate binding and get a volume before they schedule their pod.
Yeah.
That I mean, it's not the great solution, but it would be a step forward, and it would work with the concept of a subtype. And it would allow us to keep all the other behaviors we have today, where you just have, one storage class, which is possibly the default, and within it, all the scheduling happens down inside the driver, and it can take a long time potentially, and that's okay.
Yeah, it's a hard problem. And one more thing, I think before. Okay, so one more thing we wanted to talk briefly was like, if we want to go down to path of like multiple drivers, then one of the things that we'll have to do is allow a way to override driver name or change.
Right. We would need to address the migration path from the status quo to that new world.
Yeah.
Right. And that's another very hard problem that I don't want to have to deal with personally. Yeah, but I don't think that's even the biggest problem with that other strategy. I mean, it's just one of many problems.
This is like, I guess the main blocker in this one is the driver selection if multiple storage classes specified. That's like, it's blocker for not for drivers that I generally deal with day to day, like vSphere, Azure file. They are relatively simpler, but I
thought the vSphere did have this problem.
Yeah,
that was
but
one of the ones that
it's purely based on access mode. So we could.
Oh, I see. So the decision is simple.
Yeah. So we, like OpenShift, for example, can deploy a webhook or an admission hook, which could start, like if no storage class is specified in your PVC, then it will set one or the other storage class based on that criteria, and pretty much you get backward compatible behavior. And similar with Azure file driver also. So, but for if a driver requires complex decision making, it's kind of, yeah.
or if it takes a long time, right? Because we can't have admission webhooks go out to lunch for a long time.
But that's what I was talking about, like briefly. Yeah, it's admission webhooks will be slow, and the API call themselves will time out. And generally API calls have lower timeout, I guess. We had issues where, but in the grand scheme of things, like if the provisioning is delayed and your driver is making the call to making complex scheduling decision during the like provisioning, that's kind of factored into the pod startup time. Pod cannot get scheduled until a volume is until PVC is
Yeah,
bound.
but here we're talking about API server just accepting the PVC object,
Yeah,
right? Because you would have to mutate the object before it lands in etcd, and you only have a few seconds to do that before API server has to either reject the PVC request entirely or just go do something by default.
yeah. Yep.
I don't think that's enough time to at least do the level of logic we have today. We would have to do something much dumber.
Yeah, but honestly, I feel that it might be easier to get this done rather than the proposal one of subtype. Subtype might be harder to push through actually.
I mean, it's an API change, and yeah, it would be multiple API changes. We'd have to change the CSI spec in at least 2 places. We have to change the Kubernetes APIs in at least 2 places. We have to change the CSI driver object, or at least the way kubelet interacts with that object, in at least 2 places. Like, yeah, there's a, but they're all little bite-sized pieces of work, right? There's a lot of little bits of work to do, and a lot of people need to nod their heads, but no one needs to like rewrite their driver from scratch, which just feels like where we would be if we did the multiple driver thing. We'd have to tear our driver apart and rebuild it and move the scheduling basically out into another module that ran as a webhook, and we'd have to then figure out how to migrate customers off of the old way onto the new way.
Then if you have to, let's say if you have to do this for Trident, how many drivers do you have to write?
We only have 1.
No,
you mean how many
I'm
would
just
we have to write?
assuming, let's say if you have to do this multiple, is 2 enough or is it more than 2?
No, today there would be 3, and if and when NVMe shows up, that would be the 4th.
Yes, that's the problem, right?
Just
How many drivers do we need to write? Well, it's difficult. I also see this as a no sell from like our side. I actually recommended them to split driver a long time ago. It's not happening then. I don't think it's going to happen.
Yeah, I mean, I think
Sure.
Sandeep came to one of SIG calls also, and we recommended them to split the driver long back, like a year back or so, but there's inertia. Okay.
Yeah.
Okay, so I think I spoke with Jan about a little bit about like allowing a way to override change. I want this, like, yeah, we have, let's think through both the decision. If we can solve this problem or we don't need to solve this problem, that's something we can talk about in the next call. But for this, allowing a way to override change or change driver name in existing PVs, how would we do it? Like currently the driver name in the PV source is immutable on set, and
Can in general, can you relax restrictions like that and just say in the new version of Kubernetes the field is mutable, or does that break backwards compatibility?
From API perspective, you can relax API restriction, but you cannot tighten them. So this, I think, from API perspective, it's allowed. Yeah.
Are you sure? Because I mean, I can imagine bad things that would flow from that, right? If anyone is currently depending on the field not changing, they could be caching that value forever and never reading it. And then if you say, well, now it can change, then anyone who's depending on the value not changing could all of a sudden break. Now, maybe that's acceptable according to the API rules, but it feels like you could have regressions pop up if anyone was depending on the field being immutable.
No, I hear you. but from like purely obviously decisions don't happen in vacuum, but if from purely like API convention point of view, I was speaking from API conventions, like
Okay.
it's allowed
Okay.
to change the relax
It's allowed
a
to
little,
relax the restrictions. Okay.
but not tighten them after the fact.
Okay.
So yeah.
So then we would just have to go through the exercise of figuring out if anybody would break as a result of that to convince ourselves it was a safe change to make.
Yeah.
Yeah. I don't know. I mean, adding a new field is much more straightforward, right? Because you can easily describe the behavior when nobody uses it or opts out of it. You say, well, you just get the current behavior because the field is blank. But then if the field is populated, you get better behavior. And the downgrade behavior is, of course, it just goes back to the way it was. If for whatever reason you have an alpha feature and you turn it on and then you turn it off, right? You can explain what would happen there.
Okay. Yeah. How I think one of the problems with changing the driver name was like you have to pretty much train every node and like they've drained the nodes and everything before you can do that. So
Yep.
and because
why I will say for the if you wanted to have a hack to change the CSI driver name, one thing you can do today is just delete the PV and create a new one with different values and rebind it, right? Like that actually works without any API changes. Hey, because we looked at that when we were trying to figure out how to do migrations, from pre-CSI to CSI. We would play games where you can, I think, just delete the PV and create a new PV with exactly the right values and rebind it back to your PVC, and it just works.
Yeah, as long as you have this retain policy set, reclaim
right.
policy set. Yeah.
And as long as there's no pods attached to that volume at that moment, which was always the trick. Yeah.
I didn't think you needed to restart the pod in that case. I think we actually got some prototype working where you don't need to restart the pod.
To change the driver name?
To like create a new PV and rebind it.
Well, the problem is if you have an attachment that's live to the PVC, and then you go ahead and you rebind the PV, that when it comes time to detach that pod, it's going to want to use the old detach logic from the old driver, right? And the old driver won't be there necessarily. I mean, in the case of going pre-CSI to CSI, it was actually kubelet doing the detaching, so maybe that was less of an issue. But yeah, I mean, you just have this issue where like what the driver that attached it also has to be able to detach it unless the new driver like knows everything that the old driver knew, and that's a very hard guarantee to make. So
yeah, I'll need to double check on how we did the prototype, but I remember it might be maybe one because our driver is simpler and it's like the same volume ID for both drivers. So I'll have to think about that.
yeah.
I was also thinking like without an API change, could we, I mean, obviously it's an ugly hack. Could we support like overriding a name via annotation or something similar? Like if you remember early stages of CSI driver migration had a bunch of information stored in annotation actually. Eventually, I think we got rid of it. But yeah.
I don't know about that. I was not involved with annotations in CSI migration.
I think, yeah, if you enable the migration, then it used to store, I forgot, it used to store, there's still my annotations involved in the decision making actually. And but we no longer store the whole like translated spec, which we used to. I think it was PV controller which was doing that. I don't remember which controller was doing it, but someone was doing it.
I need to do a time check because we're at the top of the hour.
Yeah.
It sounds like there's still more to talk about, so we can keep the future meetings on. I guess I just really want to quickly want to ask Michelle, like, what is your feeling about the proposal that we've been talking about the last 2 weeks? Are you still strongly against it or warm to it?
I think I would want to find a solution for the case, the delayed binding case.
Yeah.
Because I think I wouldn't want to go down this path, but only have it work for like half of the features. Because then
Right.
they'll have other drivers that, other half of drivers that don't have a solution.
Right. Okay. Okay. Well, then we can maybe between now and next week think about additional approaches to address the node limit per volume in the delayed binding case, because that's hard. All right. Well, thank you, Xing. I think we better end the recording.
Okay.